I want. It is the discussion of challenging paper 3. So, up to now, we have completed 3 challenging papers, and I have uploaded the discussion of 1 challenging paper. So, it is going to be challenging paper number 2 discussion. So, let us start. Actually, this challenging paper is to enhance your math knowledge, to think of something, to utilize your math knowledge. It is not just about combined maths, not just about O-level maths, but to think, how to think smart, quickly, by using, being limited to a time frame, likewise. So with this you can improve your math knowledge, and that will be useful for combined maths as well. That is why, right? Right, so let's start. Question number 1. There they say positive integers a and b are such that 5a equals 7b, then a plus b is always divisible by. That is the question. So we have to find what is that number which a plus b is always divisible by. For that, we have to get to know about the possibilities of a and b. By the way, the condition they have given is a and b are positive integers. So by the way, what are integers? Integers are counting numbers, both plus and minus, and the neutral value, like 1, 2, 3, 4, minus 1, 2, minus 1, minus 2, minus 3, minus 4, and 0. By the way, since they have given that a and b are positive integers, they should be those positive which are the counting numbers, right? And the question is, further the condition is 5a equals 7b. Apart from being the positive integers, they have to satisfy this condition as well, or this equation 5a equals 7b. So this is the strategy I am going to use. You have to find the possibilities of a and b, at the same time a plus b. Then only you can think of with what number a plus b is going to be divided at all the times, right? So this is the strategy I am going to use. I need a alone and b alone. Once I take a alone from here and b alone from here, this is what I am going to do. So a is going to be 7 over 5b. Here b, when I make the subject b is going to be 5 upon 7a. The thing is this, for integers you can't have fractions at all. So for sure, a to be a positive integer, we had such a question, a closer question in previous challenging paper, if you remember. So a is given by 7 by 5b. A to be an integer, it cannot be any decimal number. A to be an integer, b should be divided by 5. Otherwise, if b is not a multiple of 5, a is going to be some decimal number sometimes, right? So b must be a multiple of 5. Then only that number gets cancelled out with 5 to have integer. So b should be a multiple of 5. So what are the possibilities of b then? So the possibilities of b, let us write down possibilities of b. 5, 10, 15, 20, likewise. Is that clear? Then when we talk about b is here. By the way, b to be a positive integer, a should be a multiple of 7, because it should get cancelled out with 7. So a should be a multiple of 7. So what are the multiples of 7? This is about a. 7, 14, 21, 28, likewise. Is that clear? So let us say for a given time, I have listed down here the possibilities of a and b. So now you have the possibilities of a and b. Now we have to think of a plus b. So this is about a plus b. For each of the occasion, this is about a plus b. 12, 24, 36, 48. It is obvious that according to the pattern you just have observed, a plus b is multiple of 12. 12, 24, 36, 48. So check for the number where multiple of 12 is always divisible by 12. By the way, since 3, 4 and 6 are the factors of 12, multiples of 12 are also divisible by like 2, 3, 4, 6 and 12 itself. By the way, out of those, you only have here 3. So the answer number is 3. Answer number is 1, which is the answer 3. That is 3. Is that clear? Alright, now question number 2. Question number 2. In question number 2, what they ask? In question number 2, what they ask? They ask, what is the maximum number of distinct positive integers that can have 30 as their least common multiple? Least common multiple, the common multiple and the least one. So you know the meaning, the common multiple and the least one. Right, 30 as. So you have to write down what is the maximum number of distinct positive integers. Positive integers again. So by the way, 1, 2 years, a factor of 30. 3 years, 4 no, 5 years, 6 years, 7 no, 8 no, 9, 10 years. So apart from 10, when you go forward, 11, 12, 13, 14, 15. So when you go from 15, you will never meet anything as a factor of 30 other than 30. So it is going to be 30. So how many numbers? Up to 30, that is done. Beyond to 30, you don't have any least common multiple because you have to check for the factors, no? There you have 1, 2, 3, 4, 5, 6, 7, 8. Maximum 8 numbers you have to make the least common multiple 30. That is the answer. 8. Answer number is 4. So the other answers are 2, 4, 10, 3. Cannot be 10. It is going to be 8. As per our, obvious experience, because we have listed everything down here. Right. Question number 3. Question number 3. Question number 3. A very good question. Which of the following numbers is the largest? So you have to compare. Is the largest. You have to compare. This is what I'm going to do. I'm going to write down all the answers here for you. For you to understand clear and explain better, right? So you have 5 numbers. 1, 2, 3, 4, 5. All right. The first one is square root of cubic root of 7 into 11. Square root of cubic root of 7 into 11. The second one is square root of 11 into cubic root of 7. The third one is square root of 7 into cubic root of 11. Cubic root of 11. Fourth one is cubic root of 7 into square root of 11. Sorry, that is the fourth one. I wrote down that as the fifth one. So cubic root of 7 into square root of 11. What about the fifth? Cubic root of 11 into square root of 7. So I've written down all the answers here. Now we have to compare these 5 to have the largest. By the way, before to compare, we have to get rid of these surds. By the way, when you have the root, if it is square root, it is to the power half. If it is cubic root, it is to the power 1 by 3. Likewise, once you have, let us say, a to the, nth root of a, that is going to be a to the power 1 upon a. Likewise. Clear? So, the thing is, for the root, you usually put the positive integers. So n is a positive integer. If it is 2, the power is 1 over 2. 3, 1 over 3. 10, 1 over 10, likewise, right? So here, this is the thing we are going to do. 7 into 11 will separate these. To the power 7 and to the power 11. So when we consider about to the power 7, first, it has been considered, for 7 it has been considered the cubic root, then the square root. So you know that power of a power, a to the power, so let us say m to the power n. A to the power m to the power n is the product, a to the power mn. Likewise, 7 has been considered on its cubic root and the square root. So it is going to be 7 to the power 1 by 3 to the power 1 by 2, which is 1 by 6 into 11. Again, cubic root, square root, 1 by 3 into 1 by 2, 1 by 6. Clear? So that is about the cubic root of 7 into 11 into the square root, right? Here, 11 is only under the square root, so 11 to the power half into 7 cubic root square root, 7 again, 1 by 6. I prefer to write down 7's first. So in that way we can compare easily. 7 is 1 by 6 into 11 is half. Here 7 is only under the square root, 11 is 1 by 6. It is for both. 7 is cubic root, 11 is square root the cubic root, so 1 by 2, 1 by 3. 7 is square root cubic root, 1 by 6 for sure, 11 cubic root only. Alright. Now let us further compare. In comparing, you can see for all the 7s, we have powers 1 over 6, 1 over 2, 1 over 3. Out of those, the least one is 1 over 6 power. For 7 and 11 for both, the least power is 1 over 6. So this is what I am going to do. So here altogether we have 7s. We can compare the 7s to have the largest 7. So there 7 to the power half is the largest. When we compare 11s, 11 to the power half is the largest. That is the case, right? By the way, you cannot say which is the largest out of those two, because you have to have both all together. That is the case. I mean, it is going to be 7 to the power into the 11 to the power any. Got it? Right. So this is what I am going to do. Here, it is going to be 7 into 11 all together to the power 1 by 6. Is that clear? Because 1 by 6 is common for everything. So I consider that common power as 1 by 6 since it is the least power we have. So this is going to be 7 into 11 to the power 1 by 6. This is going to be 7 into 11 to the power 3 to 1 by 6. Clear? Because it is going to be half. So the properties of integers or rules of integers I am using here, a b to the power r is ar br, right? So here it is going to be 7 to the power 3. So you have to have 1 by 2 here. Yeah, it is going to be 7 to the power 3 into 11, 1 by 6. Here 7 to the power 2 into 11 into 1 by 6. Clear? So 1 by 6 is common, then I can compare the inside with the positive integral powers other than the fractions. So this is going to be 7 into 11 to the power 2 to the power 1 by 6. We'll check again. 7 1 by 6, 11 1 by 6, 7 1 by 6, 11 1 by 2, 7 1 by 2, 11 1 by 6, 7 1 by 3, 11 1 by 6, 7 1 by 6, 11 1 by 3. Alright. Now 1 by 6 is the common for everything. Now you can compare what is the largest power of 7, 7 to the power 3, largest power of 11 to the power 3. By the way, you have to choose between, obviously, even though this has got 11 squared, it has 7 as well. Comparing with this is not going to be the largest. Then comparing with this 7 squared, this is not the largest. Then further comparing with this is not the largest. So out of these two, you have to choose the correct. So obviously 11 cube is greater than 7 cube. So the answer is going to be the 2. It is not even this. Out of the answers 2 and 3, you choose answer number 2 to be the answer. Clear? Hope the explanation is clear. In case you have any further issue, you can always talk to me. You can argue with me. Anything. Right. Now we are going to do question number 4. Question number 4. In question number 4, Sarath and Kamala each have a collection of marbles. If Sarath gives 4 marbles to Kamala, yeah, it is better always to put an unknown here. Unknowns, I mean, because it is about the number of marbles for Sarath and Kamala. So let us start. For Sarath and Kamala. Let us say for Sarath, number of marbles are B. For Kamala, number of marbles are B. For Sarath, A. Right. Then what is the first condition they have given? If Sarath gives 4 marbles to Kamala, then they would both have an equal number of marbles. Sarath gives 4 marbles to Kamala. In case number 1, Sarath gives 4 marbles to Kamala. So Sarath reduces the number of marbles from him 4 marbles. And for Kamala, it has been added 4 for them. So B plus 4. And they say they are equal now. After that, when Sarath gives 4 marbles to Kamala, this is the number of marbles Sarath got after that. Then Kamala is going to have 4 more. Right, in case number 2, if Kamala gives 4 marbles to Sarath, Kamala gives 4 marbles to Sarath. So B minus 4 is for Kamala. Then Sarath would have 3 times as many marbles as Kamala. So what is the number of marbles Sarath have then? Sarath is going to have is A plus 4, but this is going to be 3 times as they say. So equation number 1 and equation number 2. By the way, you can modify this equation to be as, so let us say this as A minus B equals A, number 1. This as 3B in A minus 3B. A minus 3B equals minus 12. A minus 3B in. So, 3B minus A, let us say. Anything is okay. But to make it easier, 3B minus A equals minus 12 plus 12 plus 4 plus 16. Now you have to find, as they say, how many marbles does Sarath have. So you have to find A according to the number, the letters we have put, unknowns. So let us find A. To find A right away, we can use the substitution because they don't need the number of marbles Kamala has. So let us substitute by 1. We don't need B here, we need A here. So from 1, B is going to be A minus 8 to 2. So 3 into A minus 8 minus A equals 16. 3A minus 8, 2A equals minus 24 plus 24 plus 16 is going to be 40. A is going to be 20. That is the answer. A is going to be 20. So 20 for Kamala, if you can find, no? Kamala, it is going to be 12. 20, 12, 16, 16. Then here, 24, 8 into 3. Okay. Right. The next. The last question, question number 5. Question number 5. Question number 5. In question number 5, ABCD is a square and P is any point inside the square. Any point. Ne? So, in question number 5, ABCD is square, P is any point. Ne? So, I'll make it here. They have, drawn 2 triangles here and shaded 2. Shaded 2. P is any point. You can choose from any point, by the way. Right. So, ABCD is the square. A, B, C, D. Clear? Further, what you have been asked, the ratio, area of the shaded, area of the unshaded. Area of the shaded, let us say area of the shaded to be, let us get it as A1. area of the unshaded, let us get it as A2. This is what we need to find it. A1 no, A2 then. To make it easier without the words, right? By the way, when you need to find area of the shaded, you need to you need to apply the formula for area of triangle. What is area of triangle? Half into base into perpendicular height. So let us have this perpendicular height as simply this as simple B. So what is the area of shaded region? By the way, by having the perpendicular heights all together, A plus B is going to be for sure side length of the square. So this is going to be A plus B, every side, right? So area of this triangle plus area of this triangle, which is DPC and APB, the sum of areas is going to be shaded area. So it is going to be half into A plus B into A, half into A plus B into A, plus half into A plus B into B, half into A plus B into B. That is, the area of shaded region over the area of unshaded region. To have the area of unshaded region, it is area of square minus area of shaded. So area of square, A plus B, A plus B, A plus B, A plus B. Because you know, to have the area of square, it is height into the width or length into the width, right? So minus the same thing, addition of those two. By looking at this addition, you can see half into A plus B is common. So again it is going to be A plus B. So minus the same thing, half into A plus B, A plus B. By the way, a special thing will happen here. So they have answers, and one answer is cannot say without any exact location of P. By the way, it is not the answer for sure, because we are going to have an exact answer. Let's see what is that. Half into A plus B, A plus B, A plus B, A plus B minus half into A plus B, A plus B. Let us think A plus B is A. So this is A, this is A over, half A over A minus half A. So half A over half A is 1, or 1 to 1, 1 to 1, or 1 over 1. It is going to be the ratio. The answer is third answer, clear? So these are not those hardest things or the complex things. You just need to simply think. You have to keep your concentration, you have to be cool. Do not keep any pressure. That is how you improve your math knowledge, clear? Nothing to memorize much in mathematics. It is about thinking smart. All clear? Alright, hope you just completed watching a good explanation on challenging paper 2. I'll soon give you challenging paper 3 discussion. By the way, before to that, try again that paper. Try again. I'll upload the PDF as well, since your papers are with me. Try further. I got it.